Soil lecture number 1, an introduction to soil. And in this lecture, we will go over different soil names and an introduction to properties of soil. Let's start by reviewing examples of failures related to soil. So in this slide, what you see is a retaining wall failure in an area where the soil was described as very limited for building, mainly due to presence of expansive clay. Clay can expand 30% more than its original volume when it's exposed to moisture and when it's saturated, and that can lead to up to 15,000 pounds per square foot of pressure. And that was the cause of the retaining wall failure in San Antonio in 2010. This slide shows another example of a retaining wall failure. This one is in Pittsburgh in 2018. A 15 feet tall concrete retaining wall fails in conjunction with a progressive slope failure, which again destroyed part of the structure, in this case, roadway. A slope instability. This one is an example of a slope instability failure in hillside. This was previously identified as a landslide risk area, and then eventually in 2015 the failure happened. Another type of failure is bearing capacity failure. Bearing capacity is defined as the ability of soil to support the loads placed on it. So when we have a load applied to our footing, and if the load per unit area, the stress, is more than bearing capacity of soil, then bearing capacity failure would happens, and it usually happens along the slip surface. So bearing capacity failure is something that we will go over later in this class, and we will design footing to avoid bearing capacity failure. Another type of failure is settlement. Settlement is downward movement of a structure, and it's caused by movement of soil particles. So we can have uniform settlement, tipping settlement, and differential settlement. And the most critical type of settlement in a structure is differential settlement. Again, we will also go over the examples to see how we can design footing to limit settlement into a certain number and to avoid failure. But now let's start by looking at what is soil. Soil forms continuously but slowly from the gradual breakdown of rocks through weathering, which can be physical or mechanical, chemical or mechanical weathering process. It is a general term referring to earth material that is particulate. Accumulation of particles of disintegrated rock, and frequently also handmade materials, forms soil. And we have different layers: clay, silt, fine sand, coarse sand, gravel, hard pan, decomposed rock, boulders, shale slate, and finally we have bedrock. Now let's look at major engineering categories of soil. So based on the size of particles, soil particles, we have 4 categories of gravel, sand, silt, and clay. So this is mainly based on size. Particles larger than 0.075 millimeters. So here, larger than 0.075 millimeter is considered or referred to as coarse grain soil. And particles smaller than 0.075 millimeters are referred to as fine grain soil. This is sieve number 200. Sieve number 200 has an opening size of 0.075 millimeters. So based on size of the particles, we can divide soil to coarse grained soil and fine grained soil. Particles larger than 0.075, coarse grained soil. Particles passing through sieve number 200 or smaller than 0.075 millimeters are fine grained soil. Then for coarse grained soil, again, based on size, we can divide coarse grained soil into 2 categories. It can be gravel or sand. Gravel is particles larger than 0.075. So the line between gravel and sand is 4.75 millimeters. So gravel is particles larger than 4.75 millimeter, but smaller than 76.2 millimeters. Sand particles larger than 0.075 millimeter, smaller than 4.75 millimeters. So gravel is between 4.75 millimeters and 76.2 millimeters. Sand is between 0.075 millimeters to 4.75 millimeters. And these are all based on USCS standard. Now, for fine grained soil, we have size. Based on size, particles smaller than 0.075 millimeters are considered fine grained soil. But the next criteria that we need to use is plasticity. So silt and clay are materials smaller than 0.075 millimeter. But now what is important for us is plasticity. Silt is material with low plasticity, and clay is material with high plasticity. So silt is particles smaller than 0.075 millimeter with low plasticity. Clay is particles are smaller than 0.075 millimeter, but it has high plasticity. So it's both size and plasticity. These are the 4 main engineering categories of soil. We have coarse grain and fine grain. Coarse grain, then again divided to gravel and sand, just based on the size of the particles. Fine grain is divided to silt and clay based on the plasticity low plasticity or high plasticity. There are four main soil names by properties. The first one is called granular or cohesionless soil. Then we have silty soils, cohesive soils, and organic soils. Granular. Granular is mainly sand and gravel or coarse grained soil. So it's when we have mostly gravel and sand. And coarse grained soil, gravel and sand, if you um, tried before, if you pick some sand in your hand, you see that the particles don't stick together. That's because there is no cohesion between the particles. So gravel and sand are cohesionless material. That's why it's called granular or cohesionless soil. Soil particles do not tend to stick together. These are, so we said that these are coarse grained soil, which means that they are larger than 0.075 millimeters. Larger particles provide higher strength and higher bearing capacity. So, granular soil, which is mainly gravel and sand, has larger bearing capacity or higher strength. It also develops a small lateral pressure. When we have granular soil, the particles are larger, so there will be higher void between the particles, which means that it has high permeability and it's easily drained because there is a higher percentage of void between the particles. And it makes it good backfill materials for retaining walls because drainage is important when we are talking about retaining walls. And it has relatively a small settlement, and that makes it a good material for embankments. So that's the first soil name. Gravel and sand, which we call them granular or cohesionless material. Then we have silt or silty soil, which is on the border between clay and sandy soil. So we had gravel, sand, silt, and clay. These are called granular soil. Then we have silty soil. The border between clay and sand. It's mainly formed as a result of mechanical weathering. Mechanical weathering doesn't cause any change in the chemical composition of rock particles. An example of mechanical weathering is when water gets into the pores of like a rock particle, and when it freezes, it expands and breaks rock particle into a smaller size. So it doesn't cause any changes in the chemical composition of rock particles. It just breaks the particle into a smaller sizes. On the other hand, we have clay, which is formed as a result of chemical weathering, which means that there are chemical reactions and there is a change in the chemical composition of the particles. So, silty soil is formed as a result of mechanical weathering. It's finer compared to gravel and sand, but still no cohesion. So when you have a silt sample, again the particles, they don't stick together, so it's a cohesionless material. It has high capillarity and susceptibility to frost action. And when we talk about fine particles, The void between the particle is smaller because they can fill the void between each other. So it's a packed material, and therefore it has low permeability and low relative density. So we talked about granular soil, silty soil. The next type of soil is clay. And when you have a clay sample, particles tend to stick together. So that's why it's referred to as cohesive soil. It's a plastic material. You can deform it without crack appearance. It's compressible. We will have consolidation in clay. And main characteristic of clay is that it expands when it's exposed to moisture, and then it shrinks when the moisture is removed. So we will have cycles of expansion and shrinkage, and this can cause a stress in our structure. Another characteristic is that there will be creep in clay, which is deformation over time under constant load. So when like in materials, when we increase load, we will see an increase in deformation. But creep is when the load is constant, but with a constant load, we still see an increase in deformation. That is referred to as creep, and that's something that we see in clay. As a result of these characteristics, there will be large lateral pressure. It's not a good material for retaining wall backfills. It has very low permeability, or basically impervious, which makes it good core materials for earthen dams and dikes. It has low shear strength. So shear strength is important. And clay is a material that has low shear strength, which makes it undesirable for engineering properties. And then the fourth name that we use for soil material is organic soil, which is a soil containing a sufficient amount of organic matter, and the percentage should be high enough to affect engineering properties. So organic soil is a spongy, crumbly, compressible material that has very low shear strength, and it's not suitable for engineering application.